Hi everybody, this is Dino Christian Prehistoric Facts. It's a Friday and I'm going to do the extra episode, which is actually going to be about top 5 Tyrannosaur studies. So I'll go from 5 to 1 that are my top 5. I'll get my honorable mention, and that would actually be the Predator-Scavenger debate on Tyrannosaurus Rex, even though it's not really that great of a topic to actually talk about, considering that it's been widely debated for so many years, and I think it's just non-debatable. I think it's just that Tyrannosaurus Rex is an opportunistic predator, which is it actually hunts and scavenges. So it actually be probably more, I would say that Tyrannosaurus Rex would be kind of like what, say, most predators are today, opportunistic. They hunt and they scavenge. Anyway, let's actually get down to number 5. But number 5 Tyrannosaur study would actually be it would actually be probably the, I would actually say number 5 would actually probably be the, I would actually go with the, I would probably say the, oh man, it's just hard to actually think of all of them, but there's just so many of them. But I would actually go with the Mary Schweitzer's discovery of the blood vessels and tissue samples that were actually found on the Tyrannosaurus Rex bone that was actually kind of cut in half, and all of a sudden she actually found medullary bone, which actually is soft tissue in the bone for female birds that actually are about to lay eggs, and this was a pregnant Tyrannosaur. And Mary Schweitzer should deserve all the credit that she deserves to actually finding this type of soft tissue in extinct animals, and that's pretty amazing thing to actually think about, is that you find soft tissue in some animals that actually are millions of years, tens or even hundreds of millions of years from the present day. Number 4 would actually be the family tree of Tyrannosaurs. Where do they belong? And that has really been the debate for many years, is where do Tyrannosaurs really fall in. When Tyrannosaurs were first discovered, they actually, because they've been finding the large Tyrannosaurs like Tyrannosaurus Rex, Albertosaurus, and Daspletosaurus, and even Tarbosaurus, so they all thought that they belonged in the Carnosauria family tree. But the thing is that when it didn't take until like the 70s to the 90s is when you actually start to see that family tree sort of changing, and that's just because they look closely at the bones, and they actually kind of realize is that, wait a minute, Tyrannosaurs and Carnosaurs are kind of a little different. They are distant cousins, but they're not really sort of like in the same group. It's because Tyrannosaurs actually belong in the Coelurosauria branch of theropods, and so that really actually kind of makes sense, is that you actually have a type of dinosaurs that actually are evolving to actually be faster and also actually start to get larger as they actually keep going up into the family tree, and they actually ultimately became top carnivores. That's why Tyrannosaurs actually started out small, and then they actually got to massive sizes at the end of the Cretaceous, and that's kind of actually pretty interesting to think about. Is that Tyrannosaurs started out small in the early or mid Jurassic, and then they got really large in the late Cretaceous. Number 3 would actually be the bite force of most Tyrannosaurs, as that's been widely debated for many years, of like how powerful is their bite force. I mean, you can actually find a lot of articles that actually say like, oh, it might be 3 tons, or otherwise it goes up to like 6 tons. I mean, you name it. But most likely scenario, it's actually at 6 tons, which is actually 12,000 pounds per square inch, which is actually very powerful for a Tyrannosaurus Rex. Albertosaurus and Gorgosaurus probably didn't have very powerful bite forces. They probably actually just have bite forces that actually are suited to possibly digging into the bone, but not really crushing it as much. You can find bite marks on hadrosaurs and ceratopsians from like Albertosaurus and Gorgosaurus. It's just that their Biforce is not as comparable as Tyrannosaurus Rex, where Tyrannosaurus Rex actually has the most powerful Biforce out of any terrestrial animal that has ever lived on Earth in the history of the planet, and that's just amazing. Number 2 would actually be the studying of the brain cases of a lot of the Tyrannosaurs. Dr. Larry Whitmer has actually done some phenomenal work of actually discovering what these brains might have looked like in terms of in the brain cases of these extinct animals, which is astounding. We can actually find out how large their sensory organs are. We can actually find out if they have good sense of smell, good sense of sight, good sense of hearing, and how much of intelligence do they have? Do they have great muscle coordination? Do they have the ability to have? Do they have great balance and agility? I mean, you name it. And it seems like that Tyrannosaurs, they have all the features of a predatory animal, which is good sense of smell, good sense of sight, good sense of hearing, and has great balance and actually can be agile, and also they actually have some pretty sophisticated behaviors, especially in terms of the cerebrum, the part of the brain associated with cognitive thinking, you know, like kind of like, say, like with a predator, you would actually say like a judging where the prey is with your sense of smell, sense of sight, your sense of hearing, and also how do you actually outbeat the prey with the defenses of the prey that it's showing you. And so that actually will actually determine whether or not that these animals would actually be able to actually get through those defenses and actually be able to get the prey and get their meal, that sort of thing. And probably my number 1 would actually be the growth stages. The growth stages is probably the most interesting of the studies of the Tyrannosaurs, because we really want to find out like how long these animals really lived, you know, in terms of their lifespan. And Sue is actually the perfect example of this. Sue actually lived all the way to her late 20s, 28 or 29 years old, and that is just astounding. You actually think, because a lot of paleontologists, before they would actually look at the growth rings of the bones, mainly like towards like the end of the ribs or anything like that, they actually estimated like how old some of these animals could have gotten, and their estimates would have been maybe like 50 to 60 years for a Tyrannosaur. But now with Sue, we actually find out that they lived a very tough lifestyle, and also they actually probably would not have lived much longer to their 30s. And so that really actually puts a stamp on to the fact that Tyrannosaurus Rex probably lived all the way up to their 30, to possibly like 30 or 31, and maybe could actually, probably the highest they could probably actually get to in age, if we can actually predict it, probably might be 35 if they actually had to live that long. But predators lived a hard life, and so it would be very hard for a predator to actually live at the age of 35. And in terms of human years, it would have been like over 100 for a Tyrannosaur, and so that would actually be very, very difficult for an animal that old to actually hunt down prey and all that sorts of stuff. But with Tyrannosaurus Rex, we see that it stayed small from hatchling to all the way to 12 years old, and when it reached 12 years old, it actually has this huge growth spurt, and throughout its teenage years, and would stop growing like at 18 or 19 years old, kind of like what humans are. Is that humans actually have a growth spurt right around the teenage years, and that is actually kind of pretty interesting. Is that Tyrannosaurus Rex and humans actually kind of have a similar thing of that kind of nature. But of course, we're very different. We actually live a little bit longer in our lifespan, whereas the Tyrannosaurs did not. And so, like with the Albertosaurus and Gorgosaurus and Daspletosaurus, those animals actually had a growth spurt probably like around, say, 9 or 10 years old, and then they stop growing by like till like they're 15, and so that would actually be the case of that. And those types of animals probably lived in their 20s, probably like their early 20s to their mid 20s. That would actually be my guess, and so that would actually be the case for that. That the growth spurt stage is actually probably the most interesting thing for Tyrannosaurs. I love the Tyrannosaur growth rates. I think that's actually kind of very interesting to talk about in paleontology, and I think it's going to be still going to be a thing to actually do, to actually find out how old some of these animals really got and when they died. You know, that's really going to be the case there. Alright, that's it for now. Now tomorrow I'll actually be doing my special episode. I'll be talking about Gigantoraptor and Eotyrannus. So those will actually be the two dinosaurs I should be talking about. But you can still send me questions about dinosaurs or any other prehistoric life by email me at dinocris71@gmail.com, or just go on my Facebook page, Prehistoric Facts of Dino Chris. Like the page, you can actually post your questions in the comment section on any Facebook post. But remember, keep your questions short to the point. You can also post them on the wall. You can also follow me on Twitter at CSGRILL. That's my Twitter page. I post pretty cool stuff on there. Also, take care of the people around you, and also for your younger people out there, make sure to listen to your parents, your teachers, and your guardians. So the most motivation you can have for good education. It's very important to have a good education. So with a good education, you get a good job in the future. Alright, that's it for now, and I'll see you guys tomorrow.